Piecewise functions. This should be our second go-round at least with piecewise functions, maybe even third. But we struggled with them back in Algebra 2. It'll be so much better this time because it's our second go-round. Why is it called piecewise? Because there's two pieces to this puzzle. If you like to highlight, you're welcome to highlight. If you don't want to highlight, you don't have to. But you got two pieces. I have a green piece, and I have a red piece. And I think we're all very familiar with what this means. Doesn't that basically mean y equals right there? So what I ask all my students to do for piecewise functions, I need you to do this with me, is we're going to make baby tables of values. So to graph this piecewise function, we are going to totally take this part, the f of x, that's y equals, and it's going to equal x. Why x? Because that's totally what this says right here. That's the first piece of the puzzle. It's literally y equals x. Then I ask you to think about what that should look like before you even start graphing it. Is it a line, a parabola, a cubic, or a square root function? What is this guy, my friends? This is a line. Then you've got different types of lines. Horizontal, vertical, or oblique. Discuss. Horizontal, vertical, or oblique. What is this guy? This is oblique because it has both variables in it. It has an x and a y. So we're going to make a little... But we're not going to graph the whole line y equals x. We're only going to graph a piece of it because they have restricted the domain. Remember, domain is about x's. And they say, yo, bro, the only x's you can use in this green function is if x is greater than or equal to 2. So this home slice is called the critical point. This is a very critical value for this dude. He will be where we start our table of values. I'm starting with the critical number. And I got to know if this actually works in this function or if it doesn't work. Does 2 count or not count? This will tell you. What do you think? Does he count or not count? He counts. And remember, that's a closed dot when we graph it. So I've actually put a little closed dot here because sometimes we might have to make an open dot. But 2 works in the green function. So far, so good with me. Then I want to know, what are some more x values that are going to be on this graph? I either have to go bigger than 2 or less than 2. So a great question you had a long, long time ago was, well, how do you know if you're going bigger than 2 or less than 2? You just do what it says. It says the x's that work for Mr. Green Jeans here have to be greater than 2. So would you like me to pick the next x value to be 3, or would you like it to be 1? Isn't that greater than 2? And I'm going to pick another one, 4. So I'm going, 2 is the very starting point. This is where this is going to start from. He's included, and then I'm going to go bigger than that. And then to find the y values, some people had a hard time with that. They're like, well, how are you finding these y values? It's Algebra 1. If you know what x is, you substitute that into the equation right here and figure out what y is. So if x is 2, y be 2. And if x is 3, shouldn't y be 3? And if x is 4, shouldn't y be 4? Do you have a question of where those y values came from? Now, how to plot these points. Always plot the critical point first. And I know it's weird, but we're going to make him a fatty boom batty. Big, fat point. 2, 2. So 2, 2 is right here. The question is it an open dot or a closed dot, though? What is it? Closed. This is the only point that could possibly be an open dot. Everything else on this graph is going to be closed dots. But this was the one that we were just saying. Maybe 2 works, maybe 2 doesn't work. It does work. It is included. So please make him huge. Fat boy, the fatty boom batty. Then the 3, 3, we're just going to plot him as a normal dude. And the 4, 4, we plot him as a normal size. It's really weird that I want that first one to be fat, but if you do it that way, you'll never connect the dots wrong. You always start from the fat boy and go through the others. So take your straight edge, go from the fat boy through the others. Start from the critical point, he's the fat one, and go through the others. There are many people who connect the dots like this. Do you see how I could have connected the dots going this way in red? But that's the wrong direction because I didn't start from the critical point. So here is that piece of the puzzle right there. That is it. If you want to highlight whatever color you chose here, like green, highlight that piece green. If you don't want to highlight, I don't care. That's your choice. That took care of the top piece. If x is greater than or equal to 2, we're using this part of the function. Next one, I'll use my other color. This will be y equals whatever it says right here. And would you believe it's just a 2? So it's not a parabola, it's not a cubic dude, it's not a square root dude, it's a line. But you tell me, horizontal line or oblique? That's a horizontal piece because there's no x's with it. We're still going to make the little baby table, just a little guy. And I have to start with an x value. The x value that is critical to this dude is 2. 2 is where this is a very critical spot. But my question is, if I had an x value of 2, does it work in this red function or does it not work in this red function? Doesn't count. There's no equal to bar, so that's like an open dot, and I indicate that with just like I circle it. That's an open dot. And then the last thing is how to choose other x values. You know, people are like always wanting to go 3, 4, 5 right after that. You know, that's bigger than 2, but we don't want to choose x's that are bigger than 2. Don't we want to choose x's that are less than 2 in that case? So that would go 1, 0, negative 1, whatever. You don't have to have that many. And then we will totally start substituting in to find y's. That's really weird because there's no x's to sub into, right? So I just want to know what y equals on all of these. And obviously, guess what y equals, my friends? Because that's the equation of this line. Y equals 2. Every single time, y equals 2. To plot these points, I'm going to start from the fat boy. Start from the critical point and make him fat. It's 2, 2, which is weird because it's a green dot already. But I'm graphing the red one, and isn't he supposed to be an open dot, right? And that's weird, though, because it was around the green one, so it's kind of filled in. When you're just doing it in pencil, it's going to look like a closed-in dot, which is fine. But just realize on this piece, it doesn't work. And then I'm going to plot 1, 2, 0, 2, and the other ones, and connect them from the critical point through the others, a.k.a. through the fat boy through the others. And there it was. There was that horizontal line, but it sure wasn't the whole thing. It was just a piece of it. It was just a piece of it. If you want to highlight that red, or whatever color you're using, you can. This is such a weird thing for students to understand, and I get that, you know. But let me ask you a real-life situation. Let's use ages. Would you believe that something is different once you turn 18? Like, does life treat you differently when you turn 18? So on this graph here in red, this is like, just pretend like from 0 to 18, you know, not including 18. From 0 to 18, not including 18, you really have no adult responsibilities, you know, legally. But then from 18 forward, right? Isn't something different happen? You can totally be accountable for all your actions. That's what happens with these two pieces. This is like, yo, this is before I was 18. This is 18 and after, or whatever. You know, it's like things are different in that situation. Domain and range has been an issue for students, so I use the straight edge test. To do the domain, since the x's run left and right, you always start smallest. I'm going to start way over yonder at negative infinity. And all I want to know is if either piece, I don't care if it's green or red, if it would run into this straight edge over here. Would that happen? Yes. So negative infinity is part of this domain. And as I move to the right, as I keep on moving, I'm still touching part of the graph. I don't care if it's red or green. I'm still touching, still touching. Then I get to this weird critical area of 2. Is it touching a part of the graph? I don't care if it's green or red. Is it touching it? Yes. And then it keeps on keeping on, right? So would you believe that went from negative infinity to positive infinity? That was all real numbers are in the domain. Because one piece said 2 or bigger, the other piece said less than 2. There was nobody left out, you know. You invited everybody to the party. 2 or bigger or less than 2. It's just sometimes they had to go to the red house and sometimes they had to go to the green house. Range, though, was something that many students struggled with. Range is about your y values, and since the y-axis goes low to high, you're going to put your straight edge as low as it could possibly go, which is negative infinity. Does either piece of this graph touch my straight edge down here? Nope, not touching, not touching, not touching. Where does it start touching the graph at? At 2. And is it included or not included? Well, that is included. 2 is included because it's nice and solid there. And then as I go higher, would you believe the straight edge is touching part of the graph all the way up to positive infinity? So that was a very slow refresher just to kind of get you. Like I said, the second go-around with these is much easier than the first go-around. Questions about this one? Let's do another one. Let's color the pieces. If you're a coordinated person, you don't have to, but use the same organizational system. My first one was green, my second one was red, so I'm going to do the same thing. And now, this is a different one. We didn't do any of these in Algebra 2. But whatever the top piece is, we're going to say y equals that top piece. Preview what it's going to look like. Line, parabola, snake, square root guy. What is this guy supposed to look like? A line, but part of it, right, because we're cutting it off. And would you believe he's also oblique because it has x's and y's. So what part of the graph is going to graph? Starting from the critical number, where x is bigger than 1. Even though 1 doesn't count, right? I know it doesn't count because it doesn't have an equal to bar. You're starting your table with 1. And you're indicating on the graph with an open dot that it's not going to count. So 1 starts. And I have to decide if I want to go 2, 3, 4 or 0, negative 1, 2. Do I want to go bigger than 1 or do I want to go less than 1? Bigger than 1. 2, 3. That's enough. You just need a couple points. This is also going to look like a ray because rays have one endpoint. This only has one critical point. If there was 2 points, it would look like a segment. That has 2 total endpoints in that case because it ends here and it ends here. But a ray has one endpoint and goes on forever. So to find these y values, you substitute in. If you put 1 in for x, do you see how we get 6 out of that scenario? If you put 2 in for x, we'll get 8 and 10. Yes, no, maybe, on where those came from? Let's plot them. 1, 6, fat boy, open, because he doesn't count. 2, 8, and 3, 10. Connect from the fat boy through the other points. You will have to do these on your test, which is on paper. From the fat boy through the others. That one isn't a big deal. We've done that many, many times. The next one is different. I think we can handle it, though. It's going to be y equals 2x squared plus 2. Preview. Do you know what shape of graph this should look like? It's going to be a parabola this time. Open and up, because the a value is positive, but only part of it. So we're really going to need a juicy table of values to graph it, because the parabola, you know, it's got a different rate of change. Which point do we start with? This one. You start with 1, and he counts. So you're going to close him in. 1 fits into the red function. Then I got to pick x's less than that, so I'm going to do a bunch. 0, negative 1, negative 2, negative 3, negative 4. Why am I picking a bunch? Because this thing's going to curve around, and I got to figure out where that vertex is and see where the breaking point is. How to find all these y values? Use your graphing calculator's table of values. Punch this guy. Will Cami be loud when she walks in? No, she won't. Welcome back, guys. Just grab your practice sheet from last time. We're on the back side of it. That means you and your neighbor get this one done, please. 2 pieces. For those who just walked in, if you're not comfortable doing this right now, you can wait and watch the video at the very beginning to see how we did it, if you want to wait. But we're making baby tables of values. Maybe your neighbor can help you if you just sat next to somebody. And I didn't pause it. Sorry, guys. Pause it now. So the first piece, you had to pick where x was less than or equal to 1. So I started with 1. It's included. And then I picked some numbers less than that, made the first point, and I said fat, go through the other dots. So make sure we had that point in the right way. Second piece, 1 doesn't count. You got to have one x value is bigger than 1. And then the domain, going from left to right. The green thing will totally run in, and it'll just be all reals. But the low to high, if I bring this straight edge back, there it is. Couldn't find it. As low as I go, it's running into it all the way up to there. And it's about the y value, not the x value, so it goes to 2, and it's not included, so that's why we put the parenthesis. Okay? stuff we've definitely done before. A few new things. First, my bad, I have an extra one on here just to see. You tell me, tell your neighbor first. What is this piece going to look like? More like a line, more like a parabola, more like a snake, more like a what? What's that piece going to look like? What do you think? This is a line. Is he oblique or horizontal? He's oblique because this is a y, this is an x, and this is obviously going to make what? A parabola, but just a piece of the parabola. And here's what it would look like if you did it. Now, okay, let's go to this one. This is a weird dude. It's actually much easier than you think, but I need your help. How many pieces? 1, 2, 3, 4 pieces, right? Let's talk about this piece. I don't even need to write a table down or nothing like that. This is so simple. This says y equals 4. Do you know what that would look like? Line, parabola, or what? Y equals 4 is line. Horizontal or oblique? Horizontal. So it's going to look like a horizontal line, y equals 4, but not everywhere. It's only going to go from between 0 and 2, if my pen would wake back up. How about this piece? Horizontal line? How about this piece? And how about this piece? Nothing but little horizontal pieces. But the interesting thing is, they've got all these different restrictions in the domain with 2 boundaries. 2 different boundaries. X has to be between 0 and 2. If you have a horizontal piece with 2 boundaries, that doesn't look like a ray, doesn't it look like a segment in that situation? And this graph is going to make what's called a step graph, where the steps are like, all the little pieces look like steps in this guy. So how to make it on paper? You have to look at your x's to see what you want your x's to go up to. Here's all the crap about the x's. What's the smallest number you see in all of these when it comes to all the restrictions on our x's? 0. What's the biggest one you see? 8. So we got to go on the x-axis from 0 to 8. I'm going to start with 0, and I can't count by ones because I don't have enough spaces. So I'm going to go from 0 to 8. Questions? Why I did that? Y values. These are all the y values. Doesn't it say y equals 4, y equals 8, y equals 12, y equals 16? What's the biggest number we got to get up to? 16. We've got 5 spaces to do it. I definitely can't count by ones. Probably can't even make it by 2s. Let's go by 4s. Oops. 4, 8, 12, 16. Finish it. Let's look at this little piece. This is the line y equals 4 right here. I'm going to just grab the whole thing for it. Y equals 4. My pen is really not cooperating. Apologize. Y equals 4 looks like this. Don't graph this. This is y equals 4. They only want that piece between 0 and 2, though. Right? Just in between these two guys, in between 0 and 2. Right? So what we do is it's going to be a step. We go to 0, 4, and we graph that point. Should it be an open dot or a closed dot, though? What do you think? Closed dot. And then we go to 2, 4, because 2 is the bigger boundary on that, but should that be an open dot or a closed dot? Open. And everything in between there, any x value I pick in between there is also going to give me a y value of 4 if I made the table. But if I go to the next step, y is supposed to equal 8 between 2 and 4. So 2 counts. So if I go to 2, 8, I have to put a closed dot there because this had an equal to bar. And then I got to go all the way over to 4, 8, but it's got an open dot. And everything in between there. If you pick 3 and put it in, it's going to give you a y value of 8 back. If you pick 3.6, it's going to give you a y value of 8 back. Make the rest of these steps for me, please. Here's our 4 pieces, just like you told me. And it's kind of weird, but you see the step graph that's made. I just set you up. Never once am I asking you to make one of these on paper. Never once. I want you to look at what this graph looks like. Where are the closed dots at? On the left side or on the right side? I could have told you that before we started. Aren't all of these equal to bars on the left side of my domain restrictions, right? And the open dots are on the right side in that case. So when you get a multiple choice question like this on my math lab, this is the exact same problem. I want you to tell me which one of those four is the first one. There's no freaking way that this horizontal, 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 horizontal four pieces is which graph is automatically eliminated. B as in boy, out. Those are oblique little steps. Are you with me on that? Then you can look to see where the closed dots are supposed to be. On the left side, which choice can you eliminate now? D has all open dots on the left side, so that's out. But the interesting question that students have is, well, how do you know if it's between A and C? Because this has closed dots on the left, this has closed dots on the left, and they're all like horizontal steps. Well, when y is supposed to be 4, that's supposed to be between 0 and 2. Here's 0 and 2. Here's 0 and 2. Here's what y turned out to be. In this case, it turned out to be way up here at 16, and in this case, it turned out to be 4. Which one of those is the correct graph? Boom. And then we'll have fun after. So the next one's really, really kind of weird. It's a multiple choice question again, and it's two pieces. Let's talk about this piece. Line, parabola. What's this guy going to look like? What's this piece going to look like? And if we look at the four choices, I know that's kind of weird, this little red highlighted piece. I know it's not highlighted on your paper, but that's the part that's supposed to be the parabola, because it's curved, you know. So we got all four of them have a little bit of an oblique line, a little bit of a parabola. I will let you and your neighbor discuss of which one you think it is. Maybe start eliminating. See if you can find a choice that is definitely eliminated. We've come to a discussion that we think D should be eliminated because there's no closed dots. And I like that thought, right? That is a good thing to see. But we can't do that for sure. Because do you know back on the very first problem where we had, if I can get back there. That's not number one. Let's get back there. Where we had the green dot and the red open dot like overlap each other in that case. Like, if this was all in pencil, doesn't it totally look like that is a closed dot? But there was an open dot in the graph also. So let's not do that too quick on this graph of D is out. I would like you to study A and tell me why A has to be out. Study that. Yep. A is out because the parabola is supposed to have an open dot with it, right? And on A, here's the parabola. It has a closed dot with it. That's a no-go. So that's a for sure out. This parabola, it looks like it has an open dot, but that could also have been from this line. We don't know where the open dot belongs. But this one, so far, is okay that the parabola has an open dot with it, right? But the interesting thing is, it's about this wacko point here, here, and here to see, like here they're separated, right? But here they're together, and here they're together. So you really have to know what's going on at this x value, which this x value in all of the places, would you believe, is 2. Isn't that happening at 2 on the x-axis? So let's figure out when x is 2 what y should be for both pieces. Let's do the green piece. If x is 2, we're going to put that in. What would y turn out to be? You guys cool with 4? And that would be an open dot. But if I put 2 in here, I should have used green, pink. If I put 2 in here, what would y turn out to be? 4, and that would be a closed dot. When I let x be 2, they landed on the same place in the graph. They landed on 2, 4. They landed on 2, 4. That throws this guy out because they land on different spots. This one's at 2, 0. That one's at 2, 4. It doesn't work that way on this dude. But here, 2, 4, same spot. 2, 4, same spot. Open dot versus closed dot. Should the dot be closed in? Did either one of these pieces close the dot? So the one that we wanted to throw out right away was actually the right choice. But I get that, you know. D is the correct answer because even though there's no open dot, it's because this closed dot filled in that open dot. But why wasn't it C? Because the line was saying it's 0. So that was a toughie. Please ask a question if you have it, because you'll definitely have a bunch of questions like this on my math lab. Any questions about I'm just process of elimination. And then the last thing then, since there's no question, is the old round down to the greatest integer. This function right here, the weirdo double A brackets, that means round it down to the nearest integer. So if they say f of x equals round down of x, and I'm going to put 0.2 in for x, could you tell me, if I had 0.2, like on a number line or something, what integer does it round down to? 0. That's it. Just round it down to the nearest integer. The goofy ones are like 3.8. 3.8, you've been trained mathematically for years since elementary school, like on rounding skills. It's like, well, I thought if this was like bigger than 0.5, you're supposed to round it up. Well, you do if they just tell you to round it. They're not telling you to round it. They're telling you to round it down, because that's the name of this function. Round it down. So if you round 3.8 down to the nearest integer, what's it round down to? 3. The negatives give people a hard time. Negative 2.6 is right now. And if you round him down, what does that round down to? Negative 3. And just an integer itself gives people a hard time, like 5. Who does 5 round down to? 5 is already an integer, so that answer is going to be 5. I would like to show you what a graph of that would look like. It's on the wall over there. If you see it, it's under the greatest integer. But it makes steps. And on the left side, these are always like totally closed on the left side and open on the right side. Here's the reason why. What if I picked any integer, like say this was the x-axis scale, any integer between, let me try that one more time. What if I picked any number between 0 and 1 and had to round it down? What if I pick 0.9? What does it round down to? That's why it would go to 0. What if I picked 0.5? What did it round down to? 0. Anything in between here, anything between 0 and 1 is going to round down to 0. If I picked 1, it's not going to round down to 1. Doesn't it go to 1 itself? So it comes up here. So they look like steps if you graph this guy, and the open dots are on the right side and the closed dots are on the left side. Nice. Let's do some homework.